This is Honors Algebra 2 Pre-Calc. We're doing 2.4, which is operations with functions. So the good news is that when you're performing operations with functions, they basically perform the same way that numbers do. If we have a sum of two functions, so let's let f and g be functions of x, and you'll see this on page 112 in your textbook. If you want f plus g of x, which is how we read this, right? F plus g of x, we would just have f of x plus g of x. Right? If we want f minus g of x, we would do f of x minus g of x. F times g of x would be f of x times g of x. And then the only one that's a little bit tricky, which is actually funny because it's arguably the easiest, but you have to note that there is a domain restriction, is if you want f divided by g of x, you just write f of x on top of g of x. That's it. Very little work. But you have to include the domain restriction that g of x can't be 0. So you must include a domain restriction. Now, what this domain restriction is, it's actually the first one of the 4 that we talked about at the end of the last video, right? We learned about the big 4 domain restrictions, and the first one we learned about is you can't divide by 0, which is why g of x, which is the denominator of this expression, can't be 0. So, let's walk through E1. After we walk through E1, I'll give you a P1, and then we're just going to kind of keep doing stuff with functions in this video and probably the next couple videos. All right, so we have f of x equals 2x minus 3, and g of x equals x squared plus 3x minus 6. So first thing we're going to do is f of x plus g of x. So f plus g of x is f of x, right? So f of x, which is a 2x minus 3, plus g of x, which is an x squared plus 3x minus 6, right? Now, oh, sorry, I always forget to inch you over. So I put the parentheses here just to show that this whole thing is f and this whole thing's g, but because this is a positive, there's nothing to distribute. I just keep all the signs the same. So this is a 2x minus 3 plus an x squared plus a 3x minus 6, and then I just combine my like terms. Nobody's like the x squared, so I just write the 1x squared. There's a 2x and a 3x, which would be a 5x. There's a negative 3 and a negative 6, which would be a negative 9. So there is my f plus g of x. F minus g of x is the same concept, except I'm going to have to watch out for that negative, because I'm going to have f of x, which is 2x minus 3, minus g of x. So that negative is going to get distributed, right? So now if you don't need these parentheses because you want to just distribute the negative as you write it down, if you want to jump right to this step, you can, but I'm going to warn you that that's probably not the smartest move, right? It's probably better to show a step of work here. If I do that, I get a negative x squared, and I get a minus x and a plus 3. Okay. Now, I threw in C for 2 reasons. There's 2 different ways to do C. If you didn't have to do B already, okay, so when we look at C, and I'm going to erase over here for a sec just to give myself a little bit of space. I want to show you that, remember that in math, there's very rarely only one route to a solution, right? So when you look at C, right, C says f minus g of 2. What that means is f of 2 minus g of 2. So one way to do this is to just find what f of 2 is, find g of 2, and subtract them, and that's totally fine. So that's one option, right? So this is like option 1, okay? Is to then find f of 2. So f of 2 would be a 2 times 2 minus 3, so 4 minus 3, minus g of 2, which would be a 4 plus 6 minus 6, so that's just a 4. So I get a 1 minus a 4. Oh, look, my answer is a negative 3. So that's option 1, and that's fine. If I had not made you do B, then this would clearly be the best option. But since I did ask you to do B, and you already know what f of g of x is, the second option is to recognize that you know that f minus g, I didn't mean f of g of x, I meant f minus g of x. F minus g of x is a negative x squared minus an x plus a 3, right? So we know this from B, right? Well, if you've already done that work in B, why not just take advantage of it and know that f minus g of 2 should be a negative times a 2 squared minus a 2 plus a 3, right? Well, that's a negative 4 minus a 2 plus a 3, which is a negative 6 plus a 3. Oh, look, it's also a negative 3. Either of those routes gets you to the right answer, and that's fine, right? I really only wanted to show you that because there's not just the one way to do a problem. If you're working within the rules of mathematics, if you're working in these constraints that make mathematics function, like how we add, how we subtract, what we need to multiply, etc., there's multiple different ways to get to the same answer, and that's great, and that's fine. If you were somebody who said, hey, I'm just going to split these apart and find each value, and that's great, If you're somebody who said, oh, hey, I already did all the heavy lifting, I'm just going to use the formula I got a B, that's also fine. All right, so I'm going to give you a P1 now. Sorry, computer fell asleep. I'll give you a P1 that's similar to E1. All right, so for P1, let's do f of x equals 5x plus 3, and let's do g of x equals 2x squared minus x minus 3, right? So for A, I want you to find f plus g of x. For B, I want you to find f minus g of x. And for C, let's do f plus g of, let's do 10. Okay, cool. So, have at it. You can pause me if you want. I'm going to go ahead and walk through all three of them. So f plus g is going to be f, which is 5x plus 3, plus g, which is 2x squared minus x minus 3. Now, I don't need parentheses here because it's a plus sign, so there's nothing to distribute. If you wanted the parentheses, that's fine. You're just going to get rid of them in the next step anyway, right? So I'm going to end up with a 5x plus a 3 plus a 2x squared minus an x minus a 3. When I combine my like terms, I'm going to get 2x squared, right? The x's are going to become a plus 4x, and I'm not going to have any constants at all because the plus 3 and the minus 3 would cancel. So that's what I'm going to get for my A. For B, f minus g, well, now I need those parentheses for sure for that second set because this negative is going to get distributed. And again, if you're able to just do that in your head and you say, hey, I'm going to jump right to 5x plus 3, making this a negative 2x, squared, plus an x plus a 3, that's fine, right? Just don't be wrong. So I get negative 2x squared plus a 6x plus a 6, right? And that's fine. All right, now, again, there's two ways to do C. You can either just cheat and use the formula from A, right? So one option is to just use A, because in A you found that this is the formula, and say that this must be 2 times 10 squared plus 4 times 10. Well, it's a 200 and a 40, so it should be 240, and that's fine, right? The other option is to actually just treat this as, so if we want, that's one option. The other option, if you prefer, is to treat this as f of 10 plus g of 10 and find those two separate numbers, right? F of 10 would be a 50 plus a 3, so 53, plus g of 10 is going to be a 200 minus a 10 minus a 3, right? So 187, right? And when I add them together, I get 240. All right, and that's also totally fine. So either way you go. All right, so we're gonna stop that video here, and then actually no, let's do an E2P2 that has multiplication and division, and then we'll stop the video after that, and we're gonna get some progressively harder problems. All right, so E2P2. So for E2, we're gonna say f of x equals 2x minus 3, g of x equals 3x plus 5. Cool. So in A, we're going to do f times g of x. In B, we're going to do f divided by g of x. All right. So, and then over here, give me some room, and we'll do a P2, same idea. Let's say f of x is negative x minus 4, and g of x is 3x plus 6. Okay, cool. So, f times g of x is just, or f times g, yeah, so it's just f of x times g of x, right? Which is just going to be the 2x minus 3 times, ran out of room, my 3x plus 5. And when we multiply binomials, we FOIL, right? So my first term is going to be a 6x squared. Outer is going to be a plus 10x. Inner is going to be a minus 9x. Last is going to be a minus 15. So I get 6x squared plus x minus 15. Now, the funny thing about the division problems is they're actually by far the easiest. My job is literally to write f of x on top of g of x. I'm just going to write exactly what f of x is on top of exactly what g of x is. This is 1/2 of the problem. So this is half of the answer. There was no math to it. I just write one on top of the other. The other half is that I need the domain restriction that the denominator, 3x plus 5, cannot be 0, which means that x cannot be a negative 5/3. That's the other half. Other half. You need both halves, okay? So you have to have the domain restriction when you do this, okay? So for P2, we're going to do the exact same two questions, right? You're going to do f times g of x, and you're going to do f over g of x. Okay, so pause me if you want or give it a try. It's entirely up to you, and I'm going to go ahead and do it. So f times g is going to be negative x minus 4 times a 3x plus 6, right? So when I FOIL, I'm going to get negative 3x squared. Outer is a minus 6x, inner is a minus 12x, and last is a minus 24. So I get negative 3x squared minus 18x minus 24. I'm going to do f over g. I'm going to get a negative x minus 4 on top of a 3x plus 6. And that's my whole answer, except I also have to do that the denominator, so there's a domain restriction that 3x plus 6 cannot be 0, which means x cannot be a negative 2. So I need both, right? So your answer for a division problem has to have both. All right, so we'll stop this video here, and then we're going to pick some slightly harder questions and talk about composition of functions.